Okay, that's good. Let's start. Um, Up to so far, we have covered three important topics. Let me write them here just for the reminder, because we are going to include one of the topic we have covered already under a geometric series. So the first topic we have covered is what is called arithmetic sequence. And then the second is what is called geometric sequence. And then number three is what is called the arithmetic series. So now today we're going to cover topic number 4, which is what is called a geometric series. So you can see the difference here is the sequence. We're dealing with the sequence and the series, of which you must understand what is going on from this. So, but now, before I even go any further, let me tell you that there's a relationship between geometric sequence and geometric series. So the very first thing which must come into your mind is the formula I've showed you the last time for geometric sequence, which is given by T sub n equal to a r to the power of n minus 1. I believe you all remember that formula. So it's very critical for what we are going to do today. So now let's just take an example like what I've done before with arithmetic series. Let's say we have a sequence given by 1 plus 2 plus 4 plus 8 plus dot 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 dot. Now, the very first thing which must come into your mind is to be able to tell if the numbers we are given here or the pattern we are given there is a series or a sequence. Can anyone tell me what is this? Is it a series or a sequence?
A series.
Why is a series?
Because of the addition number. I mean the addition signs.
Definitely, because of addition sign or a subtraction sign in that case. So, but in this case, we have an addition sign only. Sometimes you're gonna find the subtraction sign, but let's stick with these ones which have addition signs. So then now, with these numbers, we are going to introduce what is called the summation of geometric sequence, which is indicated by Sn. So now, the n is the number of terms we have. Let's say we want to get the summation of 4 terms. So summation of 4 terms in this case is going to be given by 1 plus 2 plus 4 plus 8, of which you can punch this into your calculator. What do you get when you punch this into your calculator? You are going to get a value of 8, right? So now this is the sum of how many terms? Is the sum of 5 terms. Let's give an example. Let's say maybe we want to find the sum of 10 terms, the sum of 100 terms. That is not going to be simple, I can tell you. It cannot be simple for you to get the sum of 110 because you can't get it the same way we have here. It could be very difficult for you to add the 110 and get the answer of that. So in that case, you will need to use a mathematical formula to simplify your question. So now, one of the method which we are going to use to get the summation of the pattern is what is called the geometric series, which this sums the term of what? It sums the term of geometric sequence. So it means before you use that formula, you must be able to justify that what you are given there is geometric series or a geometric sequence. So because if it is geometric sequence, that's when you can be allowed to use the formula for geometric sequence, like what I've given you under a arithmetic series. So for arithmetic series, you also have a formula for that. So now this is the idea behind of what we are going to do today. So now let me start by deriving the formula for geometric series, of which I've done the same with arithmetic series where we derive the formula. And I believe you are all able to derive the formula for arithmetic series, because that question, it even come in the exam. Like on the question I gave you on Tuesday, we had a formula, we had to derive a formula for arithmetic sequence, of which it was from the previous question paper. So in other words, I'm telling you that the derivations we are doing here, they are important for test and also for exam, because you're gonna find them there. So now we're going to cover the derivation of geometric series. So let me rub here and then start afresh so that you can see how we're going to derive the geometric series. So the geometric series, we derive it starting from what we are given under a geometric sequence, which we know T1 is the first term, T2 second term, T3, T4, up to what? Up to Tn minus 1, and then Tn is the last term of that sequence. This is a sequence because we are having what? A semicolon. So now let's change this sequence to be a series. How can we change it to be a series? We can change it to be a series by putting a positive or a negative sign there. So, and the summation of that is indicated by Sn. This capital letter S, it stands for the sum, the addition of all the terms we have. So it's the sum of T1. Now, because we are looking for the series, we change the semicolon to the positive sign. Therefore, we have T2 plus T3 plus T4 plus dot dot plus Tn minus 1 plus Tn. Remember, we are deriving the formula for geometric series. Before we use it, well, we must be able to derive it. So, but now, let me remind you about the formula for the Tn under geometric series. Is given by a r to the power of n minus 1, where a is the first term, r is the common ratio, and then the n is the number of terms. So now, tell me, what is the value of T1 if we substitute n into this formula? Can any one of you tell me what could be T1 in this case, or T sub 1? We will replace T sub 1 in this case with what variable there?
Won't it be A?
It's going to be A, yes, definitely. Where we have T1, we're going to replace by A. Because when we substitute 1 here, it's 1 minus 1, which is 0. Any number to the power 0 is 1. 1 times A, it gives A. And then for the second term, what are we going to replace T2 with if we're dealing with arithmetic sequence?
AR.
It's AR, definitely. And then AR squared plus AR cube plus dot dot. And then this one we replace by AR to the power of n minus 2. And then the last one is AR to the power of n minus 1. So that is the information we have with regard to these terms we are given here. So the terms, we can replace them with what we have down there. But now the expression is in terms of A and R and N. Okay, you can name this equation number 1. I believe you all understood how we arrived to equation number 1, because this is very critical in what okay, let me write big. Okay, let me write big things so that you can see what we are doing here. So as I've said, we are looking for the sum of all these terms we have here. Then the first term, we're gonna get it by substituting n equal to 1. And this will be 1 minus 1, which is 0. Any number to the power 0 is 1. Therefore, there we're going to have a. And then for the second term, we're going to have AR. I believe you know how we get this. You substitute n equal to 2, then you will obtain AR. And then for the third term, we're going to have AR to the power of 2. And then for T4, we're going to have AR to the power of 3 plus dot dot dot. We go to second last term, which in this case we're going to replace by AR to to the power of n minus 2. And then the last term is AR to the power of n minus 1. Do you see what I have on the board? The expression I wrote just now. Okay, let me adjust the camera so that maybe some of you who cannot see what you have there, you can be able to see. Okay, there we are. This is what is called equation number 1. This equation is very, very important. You must know how we arrived to this, because it's going to play a crucial role in deriving the formula for geometric series. So after obtaining that, you can then go to equation number 2. How are we going to get equation number 2? We are going to multiply all terms in equation number 1 by r. So it means all the terms we have here, we are going to multiply them by r in order for us to obtain equation number 2. Did you all understand what I've just said now? Because that is critical. All the terms in question number 1.
No.
Okay, let me repeat that statement. We are now having equation number 1, né? So on that equation number 1, all the terms on that equation, we are going to multiply them by what? By r. This r we have here is going to multiply all the terms. This is the first term, second term, third term, fourth term. We are going to multiply all of them by r. So let's multiply them and then you will see what you have. So now let's multiply Sn by r. We're going to have r Sn. When we multiply a by r, we're going to have ar. And then this, when we multiply by r, is going to be ar squared. And then this one is going to be ar cubed. And then this one is going to be ar to the power of 4. Plus dot, dot, dot. And that side, when we multiply this by r, is going to be ar to the power of what? Of n minus 1. And then the last one is going to be ar to the power of n, like that. So that is the information we have now. After multiplying equation number 1 by what? By r. And this will be equation number 2. I believe you are all with me. If you did not understand something, don't hesitate to let me know. I will explain that again. So after having equation number 2, we are going to go to the next step now. The next step is for subtracting equation number 1 with equation number 2. Let's subtract and see what we obtain. So it's this minus that. So if we subtract Sn by Rsn, that is what we're going to obtain. Equal to, then now let's subtract A with AR. What do we get when we subtract A with AR? Are we together? I don't have to lose you, ne? Are we together? Are you guys with me? Okay, let me continue. See what is going to happen here. So you can see that if we subtract this equation number 1 with equation number 2, this term is going to cancel with that. Why? Because they are the same, eh? This term is going to cancel with that term. This term is going to cancel with that term. Other terms which are inside the dots is going to cancel with that. Same here. This term here is going to cancel with that. This is going to cancel with that. Even this one is going to cancel with the term inside. So now that simply tells us that in this subtraction of the two equations, we're going to be left with A on the first minus AR to the power of n on equation number 2. So then after having that, we can then take out the common factor on the left-hand side. So it's going to be Sn into 1 minus r equal to, and this side is going to be A into after taking out the common factor, is 1 minus r to the power of n. We divide both sides by 1 minus r. We're going to left with Sn, which is equal to a into 1 minus r to the power of n, all divided by 1 minus r. This is the formula which you must not forget. Whenever we talk about geometric series, we are referring to this formula we have down there. We have derived the formula now. So tell me if you did not understand something there so that I can elaborate before we go to the property of that formula and then we do examples. So it's your time to ask questions where you did not understand from the derivation we now have on the board. So this is your time to also take the screenshot of that so that you don't misplace this. Okay. Are you fine with the formula we have on the board? Ask me any questions with regard to this formula we have down there. It's your time for question now. Let me give you 2 questions to ask. I believe some of you are disconnected because of network. So with these 2 minutes, I think others they will be rejoined before we go to the questions. Any question with regard to the derivation we have on the board? As I've said, this is geometric series. Take note of that. It's geometric series. Okay. Let me go to the properties of this formula we have down there. Sn equal to a into 1 minus r to the n divided by 1 minus r. So we are now going to the property of these formulas. So let me wrap what we have out there. So we have this formula of Sn, which is equal to a into 1 minus r to the power of n, all divided by 1 minus r. Okay, now, this is the first property which you must know about. That this formula, you can use it only, the first property, you can use the above formula only if r is less than 1. That is the condition we have there. That the above formula we have, we can only use it when r is what? Is less than 1. Do you know what? Is because we are avoiding a situation wherein this expression or this equation is going to be negative. So if r is greater than 1, let's say it's 2, you're going to have 1 minus 2, which is negative 1. So that case, we don't want it in this case of equation. So r must be less than 1. For example, if r is 0, so it's 1 minus 0, which is 1, and that will be positive. Therefore, that is fine. And now, there's a second formula of which you use when r is greater than 1. So the formula you need to use when r is greater than 1 is just an exchange of the variables we have up there. So it's going to be a into r to the power of n minus 1, all divided by r minus what? Minus 1. So that is another formula. So it's exactly the same thing. is that you can see we swap the position, of which you will derive it in a different way. There's nothing which you're going to change, but just take note of the fact that the difference between this formula is the positions, and the reason for swapping the position is for accommodating this condition, that this formula we have here, we can use, let me say, use it when R is greater than 1. The other one, you use it when R is less than 1, and then the other one, you use it when R is greater than 1. And for both the formulas, R must not be equal to 1. Why it must not be equal to 1? Because if it is equal to 1, R minus 1 is 0. R1 minus R is 0. So that it's a must that R must not be equal to 1 in this case, because this is not going to work if it's equal to 1. Are we all together? It's your time to ask me where you do not understand. So we have covered just one aspect up to now, the derivation of this formula we have here, of which we call it a geometric series. I don't expect you to know much about that now. So we're going to cover the detail of that immediately after this. So by now, just take note of the derivation which I've given you, and then the formula of a geometric series and the conditions of when exactly do we apply the first formula, when exactly do we apply the second formula. So you must know this information. It's very critical. As I've explained to you, you apply this when R is greater than 1. You apply the first one when R is what? Is less than 1. Can we go to the examples? Okay, let's quickly rush to the examples I've given you on the pattern. So I'm going to wrap everything we have on the board now. So I believe all of you, you will be listening attentively on the examples now, because that is what is going to solve the problems you have with regard to geometric series. So now I'll just pick one example from the ones we have. Okay, let's start with this one. So from this question, we are given the sum. So the sum to n terms. So it means this formula is for the sum of all the terms in the sequence or in the series. Of numbers is given as n equal to n over 2 into 5n plus 9. So now the first question requires us to calculate the sum to 23 terms of a sequence. Then question number 2, it says, hence, calculate the 23rd terms of the sequence. Okay, this is the information we have. Let me check if you are all here, because I'm going to explain important stuff here. So we are given a question, and we're required to apply the information I've given you of arithmetic series and arithmetic sequence, series and geometric series. So now, this question requires us to, we're given the sum to n terms of the sequence of number is given by Sn. Whenever you see this guy, just one thing must come into your mind. What do we call it? The sum. So the sum of the sequence is equal to n over 2 into 5n plus 9. In other words, we are given a formula for finding the summation of terms here. Okay, now the first question says, calculate the sum of 23 terms of a sequence. Let me take you back to that example I've given you of 1 plus 2 plus 4 plus 8. Now, if the question say find the sum of 3 terms, what could be the answer of that question? We're given this series here, and the question says find the sum of 3 terms. The answer for this will be equal to what?
7.
It's going to be equal to 7 because you just have to add how many terms? The first 3 terms, and then you get the answer. Now, let's go back to the question we are dealing with here. It says calculate the sum of 23 terms. So, but you can see that here we are not given a series like what we have here, but we are given a formula that represents the series of any terms of n terms. So what you are required to do in that case, where we have n, we're going to substitute what? We're going to substitute 23 on that formula. Then you will have answered the first question that we have there. So now let's substitute and see what we get. So we're going to have S23, of which you read it as sum of how many terms? Of 23 terms, equal to 23 over 2 into 5. The number of terms is 23 plus 9. Can you put this into your calculator and tell me the answer you get? What is 23 over 2 into 5 multiplied by 23 plus 9?
It is 1426.
1426. Okay. Now we have answered the first question. It was very simple, but now the problem is on the second question, which say whenever you see this word hence, it simply tells you that you're going to use the information you obtained from the previous question. Are we all together? So now we're going to use the information we obtained from this first question, which say hence calculate the 23rd term of the sequence. Now we are looking for exactly the term that we have on the 23rd. Let me give you again example of the previous sequence, because this is simple to deal with. Now, this is the sequence we have here. We obtained the sum of 3 terms as 7. But now, if the question say calculate the 23rd term, for example, let's say calculate the 3rd term of that sequence. What would be the 3rd term of this sequence we have here? What is the 3rd term of this sequence we have there?
4.
It's 4, yes, definitely. You just go and spot out the terms were given here, and then you will have the 3rd term, which is given by 4. So, but now here we are dealing with a different thing. Okay, in this example, we need to have the semicolon, maybe to avoid mixing things, because I'm going to explain something which is very, very important that applies what we have there. Let's say we have a sequence. Again, I'm going to give an example by the sequence we have there. It's 1, 2, 4, and 8. So then now, if we want to get the sum of this sequence, let's say sum 1. Sum 1 of that sequence is going to be what? It's going to be 1, eh? And then what will be sum 2 of that sequence? Can any one of you tell me the sum 2 of this sequence we have here? It's going to be 3, yes, definitely. And then sum 3 is going to be what? We have done this, is 7, eh? And then sum 4 is going to be 15. Yes, definitely. Okay, how did we obtain sum 1? Sum 1 is T1, eh? How did we obtain sum 2? That is very critical. Can anyone of you answer me on that one? How did we obtain sum 2?
T1 plus T2.
Yes, it's T1 plus T2. Take note of this, it's very, very important. That sum 2, we obtain it by adding T1 and T2. And then sum 3 is T1 plus T2 plus T3, ne? But T1 and T2, we know is equal to something. T1 plus T2 is equal to what? Is equal to S2, ne? So it means where we have T1 and T2, we replace by S2 plus what? Plus T3. This information is very critical. It's the one which is going to help us to answer the second question there. Let's go to the last one. The last one is going to be T1 plus T2 plus T3 plus T4. But we know T1 plus T2 plus T3 is what? Is at S3, right? And then plus what? Plus T4. Okay, now we have S4, we have S3, and we have T4. So now let's say the question requires us to find T4 when we are given the summations. So you just have to make this T4 the sum of the formula. So in other words, what does that teach you? It tells you that whenever you want to get the terms, from the summation, you need to use this formula that we have there. For example, let's say we want to get term 4. Term 4, you can get it from summation by saying T4 is equal to, you take this to the side, you will then have S4 minus what? Minus S3. This formula is very, very important. We derive it from this. In order for you to get T4, you subtract S4 with what? With S3. Now, let's go back to the question. Let's answer the question now by using the information we have done there. We say calculate the 23rd term of the sequence. How are we going to get the 23rd term? It's going to be T23 equal to what? Can anyone tell me what T3 is going to be, T23 is going to be equal to? Is going to be equal to S what? Is going to be equal S 23 minus what? Minus S 22. I will need to do another example which requires this so that you can see how we obtained that. This information is very critical. So we obtained a term from a series. So by saying, in order for us to obtain the term, we say summation of the current term minus the summation of the previous term. Then you will get the answer you are looking for. So therefore, T23 in this case would be equal to T23. We have it already from the previous question. So that's why the question says hence. It's because we're going to use the information from the previous question, of which we find to be 1426 minus. Can you tell me what is what is S22? S sub 22, it gives you the answer of what? Just put this into your calculator. Where you have n, you substitute 22.
1309.
1309. And then can you subtract these two numbers with your calculator, and then you'll have the term that you are looking for down there.
117.
117. So this is the term we are looking for. What does this question do? It connects the series and the sequence of geometric. So it connects the two. That is very, very important. You must take note of that. So we connected the series and the sequence. So this is how you're supposed to get the terms from the sequence. Okay. Must I do the second question? But it must be different now. Let me do a different question. So I'm just going to rub here. Instead of having a formula, we now have numbers. 2 plus 4 plus 8 plus ... up to infinity. Questions are the same. We are answering the same questions. Calculate the sum of 23rd terms of the sequence. And then the second question says hence. Calculate the 23rd term of the sequence. So let me wrap here and then we do those questions together. Where